Good thing. Okay, so let's get started. Hope you had a good St. Paddy's Day. Are there any questions? So what's happening next week? Midterm. Are there any questions? Yeah.
Are we going to be receiving another review?
Yeah.
Sheet?
Yeah. So I'll give you another review sheet like I did for the first test, and then maybe if you're all nice to me, a second sample test. So.
You're so pretty.
Wrong adjective, but thanks anyway. Yeah, go ahead.
Is it going to be from functions down?
Yeah, so it's from whatever midterm 1 ended at, the thing right after it, until whatever we're going to get to, let's say on Wednesday. We'll probably get through arrays, so then maybe it's through arrays for that. But it's a red herring to say like it covers this material, because like if you're going to be writing some code, then you might be using some loops and some if statements. But I'm not explicitly asking you to use that, but you might need it anyway. So it's disingenuous to say that like it's only on this, because then someone will say, oh, we had this to do. So yeah, just note that I'm trying to test the things after midterm 1, but it could use some concepts from earlier if you decide to use them. Other questions? Okay, so we're actually a little bit behind, so I'm gonna start moving a little bit faster. So we've been talking about arrays for a little bit now. So arrays hold a bunch of stuff in one structure. So if I want a bunch of integers all in one place, an array is a good thing to pick to do that. If we want to access some element of the array, either set the value or get, we use the square bracket operator with the index that we want. What do indices start at for arrays? 0. And if there are n elements in the array, what is the last index? n-1, because it starts at 0. Good. Yeah, so we talked about various ways we can loop over the array, either through an index or the range-based one. Depends on what you want to do. Then what you could do in some cases is you can modify the contents of the array. So actually, let's just start here. So for the range-based for loop right here, we could actually put a reference on the variable itself, so that we can actually modify the array as we're looping over it, which is kind of cool. So if we have 3 integers in here, and I'm going to do a range-based for loop here, and then what's going to happen is I'm going to see in the score variable, but notice it's a reference here. So therefore, I'm going to be changing the value inside of the array. So I can put a reference on the range-based for loop just like we have been putting references inside the function parameter. So instead of just passing something by reference, I can just do references right here, exactly the same way. So this is a way that if you want to initialize all the values by having the user input data or something, just use a range-based for loop with a reference on it, and you're all set. You could just say for int I equals 0, I less than the number of elements I++, and then C in grades of I, grades at index I. That'll do the exact same thing. But this is just a little cleaner to do it this way. Okay, so we went into much detail last time over this thing, so hopefully we all understand this. But there's no checking whether you go past the end of the bounds. So if there are 5 elements in the array, so the valid indices of an array of 5 elements are what? What are the valid indices? 0 through 4. So there's no check whether or not I access index -1 or lower, or 5 or higher. So if I access outside the bounds, it doesn't actually do any bounds checking for me. It doesn't stop the program or whatever. So if I do something bad, I may overwrite some other memory accidentally, or if I'm a hacker on purpose. So try to stay within the bounds. We'll talk about something called vector, which will avoid this type of issue. But so try not to use arrays if you can. Use vector. But this is just a red herring if you try to access outside the bounds of a normal array like this. Okay, so we talked about that last time. One of the biggest errors in programming is something called off-by-one errors. So we actually kind of saw this before. So let's just say we have an array of 5 elements, and I want to loop over the elements in the array, and I hate the range-based for loop for whatever reason. So I'm going to stick with the indices and just say, I'm going to start my loop at index 0, and I'm going to go, let's just say the variable's I. Then I'm going to go up to I less than or equal to 5. So what is wrong there? It's going to be off by 1 because I is going to, once it reaches value 5, it's going to say the condition is still true. I'm going to access index 5 even though it's not a valid index. And so that is an off by 1 error, because what I should have done is I should have done I less than strictly 5. So not less than or equal to 5. So that is an off by 1 error, where very commonly you meant to have strictly less than or greater than instead of less than or equal to, or the other way around. So you have to be very careful on, if you're going to be using indices in your loops, you have to be very careful whether or not you're going past what you want to. So maybe what you wanted to do is print every second element. So not 0, 1, 2, 3, 4 indices, but instead 0, 2, 4, 6, 8, whatever. What if the last number is an odd number? Do you want to check less than or equal to that number, even though you'll never hit it? Or less than or equal to the one before? Or less than the original number? So there's a lot of ways you can actually approach this, and a lot of ways to get it wrong. So be very careful when you're doing loops with indices, because you can be off by 1. So that's why, one of the reasons why I advocate using the range-based for loop, because you never encounter this. So you'll never encounter an off by 1 error if you use the range-based for loop. So just use it. But sometimes you really do need the index. Okay, any questions on what an off by 1 error is? In fact, you should never actually use a loop with indices, and here's why. So let's just say I am doing, for every integer I in the array, I'm using a range-based for loop. I'm doing good. So I'm actually going to change this name to val for a reason you'll see in a second. Suppose, well, val is going to get the values inside the array. Let's just say I initialize them. It's not that important what they are. So the val right here is going to get the values inside of the array. But what if I actually want the indices? So I want like the first val being index 0, then the second one being index 1, 2, 3, 4. What if I wanted that instead? Could I just use the normal loop where I just say for the index equal to 0, the index less than or equal to 4, which is the highest index, I++, and then just access the ith element? Could I do that too? Yeah, I could have easily done this. I could have just said for int I equals 0, I strictly less than 5, let's say, to make it consistent. Then I can access array of I. So I can just access the array element like this, or I can do this. Either way is okay. So, of course, what is the downside of using this approach, the normal loop, as we've just discussed? It could go out of bounds if I mistyped and put less than or equal to here. So what if I really do need the index and I want to use the second approach? What could I do?
Define val outside of the for loop.
Not val, but I'm going to define the index outside the loop. And then, so the starting index is 0, and then every time at the end of the range-based for loop, I increment the index. So the index here at this point is I, and the value we want is val. So here, what I could do is just say, I'm going to avoid the off by 1 issue because I'm not accessing here array of I, even though I'm looking at the corresponding index. So if the range-based for loop is giving me the value, I don't care what the index actually is. But if I really do need the index, I can augment the loop this way by just saying, I'm going to make a variable on the outside, set it to 0, and at the end of the loop, I'm going to do the increment. So this is kind of like the normal loop where we do the modification after the loop body. Here I'm putting it at the bottom, which will do the same thing. So if I wanted the index in addition to the value from the range-based for loop, I can modify it easily. So for this reason, I actually don't think there's ever a reason why you should use the normal loop over the range-based for loop. Actually, there are reasons, but the default way we've been using it, always use the range-based for loop, and if you really do need the index, just augment it simply like this, by putting the index on the outside, set to 0, increment at the bottom of the loop. And then you can work with the index in the middle, however you want. Okay, any questions on that? Okay, so yeah, that's an off by 1 error. So yeah, so comparison of loops. It says that sometimes you want to do one or the other. I pretty much always say just use the range-based for loop and add the index if you need it to. So yeah, you can always convert one into the other, so there's really no difference between them. It's just one is less susceptible to programmer error than the other one. Which the range-based for loop is less susceptible to error. But you could use either one. Okay, what if we wanted to initialize the array? So if we go back to the program here that we had, what did we learn by just having the array initialized like this, or created like this? What do we know about the values inside the array right here? Well, they're integers. Obviously, they must be integers. Although that's not technically true. But what are the values of the elements in the array?
Well, it could be anything.
Could be anything, as we have seen before. Mostly they were initialized to 0, but sometimes they had this weird value, this random value. So what if you wanted to, what we could do is just say, I'm going to loop through the array, and I'm going to see in the value of the array over and over until I initialize the array. That's kind of what we did up here. Where is it? Here. So I could just create the array right here, loop over it with a reference so that I really do modify the array, and then I can see in the corresponding value. And then that'll change the value inside the array. But what if you wanted to initialize it all in one line, which would be kind of cool? So what this requires is that you know all the values that you're going to need. So yeah, you have to know all the values at compile time, let's say. I'm lying a little bit, but let's just say at compile time. Then what you can use is what is called an initialization list. So I'm not going to actually test on this, but it's just that you'll see this more often than not. People, instead of just creating an array like this, and then just setting the index 0 to this, index 1 to this, 2 to this, then what you can do is use an initialization list, just initialize the entire thing all in one line. So it's a little nicer to look at. So the terrible thing about it, though, is that we know that there are 5 elements on the right, but we have to write that there are 5 elements on the left side, too. So where I size is equal to 5, we have to put in the brackets right here that there are 5 elements, even though the compiler knows that there are 5 elements on the right side. So this really only is beneficial if you have a small number of values that you know at compile time. So that's the only reason why you would ever want to do this. So if you have an unknown number of values, or you don't know what the values are at compile time, then you need something else. Either the loop we did before where you just do the cin business with the reference, or a different thing that we'll talk about in a bit. So I'm not going to test on this. You'll just see this when you look at code that people write today. Okay, so let's process some array contents. The elements themselves, so this is lying a little bit. It's not technically true, but it's good enough for our purposes. So you can think of the array elements as just values. So if I look at an array of index, at index 0, for example, and let's just say it's an integer, then the value that's stored in there is an integer. Then we look at the next index, it's another integer for the next index, all the way through. So we can just use it in any calculation that we want. You can think of it like a variable too, because we can set and get the value in the array at that location. So you can think of it as a variable too. So just use it in any calculation that you want. So I'm not sure why you would ever want to do this. So what's the issue with this? So look at this code right here. What is something that's kind of annoying about it? Let's just say it is correct. But what is annoying about it? Yeah, it's repetitive. So what's repetitive about it?
It's the same statement.
Yeah, so this principal amount 3 thing, whatever it is repeated. So what if like I changed the structure at a later point and now it's index 4? What do I have to change here? 3 to 4 at every place. What's a better way? Well, what we could do is just say, well, is principal amount 3 changing at any point in this code? No, we're just getting whatever the value is. So what we can do is just say, save it to a variable, and then just use the variable at every point. And then we're okay. Question, what is the type of the element at principal amount of 3? Do you know? No, we don't know what the declaration of principal amount is. Does it matter? Not if we use auto. So that's another reason why you want to use auto. So here, I don't have to look at any other piece of code anywhere else in the entire program. All I can do is just say, save it to a value. I don't care what the type is. Let the compiler figure it out. And then just use the value at each one of these places. So let's just say we have auto val, for example, is principal amount of 3. And then here, we can just say val at every place. Isn't this a lot easier to read? And more importantly, it's more maintainable. So that if I change this at some later point, I only have to change it in one place. And so I don't have to worry about any other place where this can appear. So this is really, really nice. And another thing that's really helpful is, what if I change the type of principal amount, the array itself? Does this adapt to that? Yeah. So this is really maintainable. So I only have to change one thing in one place throughout the rest of the program. Whereas before, I had multiple places, and if I leave one of them out, then something bad can actually happen. Any questions on that? Okay, so let's copy arrays now. So this is another reason why I don't like arrays, is that you can't just write a simple statement like this to say, I'm going to just assign to another array, and I want to copy all of the elements from the tests array on the right to tests of 2 on the left. So I want to copy the elements from here over to here. But this doesn't work. Can anyone explain why this doesn't work? So what happens here is that tests, the name itself, tests, is an address, a memory location. And tests of 2 is also a memory address. So what you're trying to do here, really, is you're trying to assign a memory address to another memory address. Does that copy the values over? So I want 2 independent copies of the same values. No, that doesn't copy. So what you could do instead is, so this would be a legitimate use case of using the actual indices. So here what you can do is just loop through the tests array, and at the same index, just assign whatever values in here over to here. So if we have, let's actually just do a small example. Oops, nope, I don't want a new folder. So let's just say we have the tests array right here. Let's just say it has 79, 10, and 0, our favorite example, and test 2. Test 2 equals, let's say, 42, 23, and 10 again. So let's just say I was wanting to do this statement up here, this one right here, where I want to copy the values over. So what should tests of 2 have as values after I really do copy the values over? Yeah, 79, 10, and 0. So here, I want to overwrite the values inside of tests of 2 to be the ones in the tests array. So let's see what happens. So let's look at the code that actually does the copy. So let's look at index 0. Then what is the element at index 0 of tests? 79. And then we're assigning to which index of the test2 array? The same index, which is index 0 in this case. So here, 42, what does it change to? 79. Do the other values in the array change at this point? No, good. So then we increment our index. We're at index 1. Then we look at index 1 of the test array, which has value 10. And then we're trying to overwrite which value? 23. And so then we overwrite 23 to be 10. And then similarly, we overwrite 10 to be 0, as we expect. Any questions on, so that should be pretty basic on how that works. What if instead, let's just say we have 79, 10, 0, and I'm going to augment the test array just to be crafty. What if we wanted to shift the first 3 elements forward 1 position, and then move the 0 back to the start? So this is what is called a cyclic shift. So I'm cycling through the values. Every value in the array gets moved to the right 1 position, except the last one, which gets moved to the first position. What could we do? What could we write for that? So let's set up the array first. The loop first. Well, let's see. What is the highest index of array in this case? 4. So what are we trying to do? I'm trying to move the element at index I to index what? I plus 1. Well, should I move index 4? Well, at this point, no. Because if I try to move index 4, it'll be assigned to index 5. Is index 5 a valid index? No. So what should the loop go to as its stopping condition up here? I less than 4, okay? Because I want to stop one early, and then after the loop, we'll do the final one, which is moving the last element to the beginning. But there's a problem with that. Yeah, go ahead. Ah, great point. So if this loop is going to be moving all of the elements, the first n-1 elements, forward one position, then that last index is going to be overwritten potentially with some other value. But I want to preserve that value so I can move it to the front. But I can't, at the beginning, just say move the element to the front because I might overwrite the index 0 value. So what should I do? Save it to a variable. Good. So I'm going to make a temporary variable to be array of 4. So array of 4 is the last index, so I'm just going to save it. What if I did this instead? So at some point, I'm going to be overwriting this value. Will temp change as a result? Yeah, because it's a reference. So here, I really do need temp to be a different variable, a different memory location. So it's a copy. Okay, so let's do the meaty part of this. So how do I actually write the code inside here? I want to assign the. Oh, that's a problem. So think about what happens. Let's just say at index 0 and 1. I'm going to be let's just say I'm trying to assign index 0 to index 1. Let's just say I do that assignment. What happened to the old value of the array of 1? It's gone. It was overwritten. So what could I do? I can save it to a different temporary variable too. So what is the value that I want to save? Well, do I want to save the index at I or I plus 1? I plus 1. That's the one I want to save. So I plus 1. Let's see. But here's another problem. So here's what I wanted to do. I want to assign I plus 1 to be array of I. So I'm trying to move array of I into I plus 1, right? What do I do with temp now? Yeah, but then I need to assign to I plus 2, and then, yeah, that's a little problematic, right? So let's actually think about how to actually do this.
Well, it wouldn't make a difference if you went the other direction, top down.
Ah, that's what I wanted to get to. What if I did it the other way? Suppose that I looked at the second to last index and the last one. So then I do the assignment, move the second to the last one. Do I care now about what that last one is? Well, I saved it. Well, then let's move back one position. Then I try to assign the third to last to the second to last. But I've already moved it, the second to last one over. So I don't care what the value was. So I don't need to do any saving now.
We need to change it to int I equals 4.
I equals 4 now. And then what is my condition here?
I
Greater than or equal to?
0.
Yeah, equal. You need the equals here because I want to access index 0. Are we done with the for loop? What did we need to change? Minus, minus. We're going downward now. Okay, cool. So this really does work because when I do this modification, the value that I just overwritten, I'm not going to need anymore. So therefore, we can just iterate from the back to the front now. But then we have one last bit of business at the end. What do we need to do?
Well, we need to change array I plus 1 just to array I equals array I plus 1.
No, I'm just moving the value. I'm not changing it. I'm not modifying the value. I'm just shifting all the elements one forward. So if this is the array we had before, then what we want is 0, 79, 10. Let's actually change this value to see it happen. This is what I want. I want to shift all the elements forward one position, except the last one, which gets moved to the front. So we actually have one last bit of business to do here, which is what at the end?
Assign.
Yeah, array of 0, which will be given what value? Well, it can't be array of 4 now. It has to be temp because array of 4 was overwritten. So you have to think a little bit, because if I overwrite the value of an array element, the old value is gone. It's not saved anywhere. So you have to be a little bit careful about how do you access elements. So the fact that all we had to do is just change the for loop and how it behaves will get us a dramatically different result than if we just accessed it from forward to the back. So just think about it a little bit, yeah.
Don't we have an Offbyone? I should equal 3 instead of 4?
Great point. We do have an off by 1 error, which is we need this to be 3.
There we go.
Great point. Great point. So even I make mistakes. So yeah, big surprise. So yeah, you need to start it at 3 here because we're accessing at I plus 1. Good. Other questions? Okay. Yeah. So it says here with vectors, this does a copy. We haven't talked about vectors yet, but they'll save our souls. Okay. So suppose that instead of just copying the values over, maybe we have some secret password, which is the user has to enter a sequence of numbers in some order. So maybe we can think of that as a password. Then what you want to have happen is we store the secret password in the code. Bad idea, but let's just do it anyway. Let's have the array stored in code, and then we have the user enter the corresponding numbers, and then all we have to do at the end is just check, did they enter the right sequence of numbers in the right order? So you may then want to check, are the two arrays having the same value? Well, we can't do this if check at the front, because why? Because those are the memory locations. There are some legit applications where you do want to check if the two arrays have the same starting address. You may want to do that sometimes. But the vast majority of the time, you want to check the actual values for equality. So why do you think the code down here is way more complicated than the one we saw from the copy part? Why do you think this one is way more complicated? What if the two arrays have different sizes? So let's just say the first one has 10 elements and the second one has 20 elements. Do we have a way of checking that do we have a way of figuring out what the size of an array is natively? No, there's no way. Well, there is, but there's no way we've seen. So let's just say we don't know the size of the array. Well, what could happen is if I'm just marching through the two arrays, just checking the values as we go, well, if one of them is longer, then I'm going to do something bad with regard to the shorter one, because I'm going to be going into memory that's not allocated for the array. So that's why this code is more complicated. So what we need to do here is there's actually something that is a little bit different here. So this I size right here is not the size of the array, either array. It's actually the minimum of the two sizes of the arrays. So if one of them has size 10 and the other one has size 20, yeah, so then, yeah, you have to have I size be equal to 10 in that case. But this code then, for that reason, is wrong, is not correct. Why is it not correct? what if the 10 size array and the 20 size array agree on the first 10 positions? And then the other one has whatever values for its last 10. Well, are they equal?
The program's going to say it is.
This program's going to say yes. But are they actually equal?
No.
They're not identically equal. They are what is called prefix equal, which means that the starting positions are the same. Maybe one of them's longer, but the starting positions are the same. So this is a problem because there is a way, but we don't know of a way of figuring out what the size of the array is. So this is actually a little bit problematic. What you usually do is just say, well, if both arrays are the same size, this does work. This is fine. So if they really are the same size, then I don't really care. But if they are different sizes, that is an issue. But there's really no issue here because when we declare an array right here, we have to know the size to start with anyway. So if we're declaring it with a different size, well, then you know you're going to run into issues anyway. So this isn't really that big of an issue right now. But when we talk about dynamic memory, this will become an issue. But the principle of checking equality here is you march through the array with the same index, look at both of them at the same point all the way through, and if at any point they are different, then you just say, can they be equal? If they are different at any place. So if we're marching through at the same index on both arrays, and they have the same value, same value, same value, same value, different value, can they be the same? No, they can't be the same. So that's the principle behind checking quality. Any questions about this? Okay. But let's just say we want to actually do something useful now. So maybe we want to know what is the sum of the elements in the array, or what's the average, or standard deviation, or whatever statistic you want. So these are really simple. No issue here. So we just start at 0, go to the last possible index, and then just look at the array at that index, and then just add to a sum variable which we started at 0. So if we had 79, 10, and 2 like we had before, then the first iteration we're going to add 79 to sum, next iteration we're going to add 10, last iteration we'll add 2. But of course the range-based for loop is here to save us, so you can actually use the range-based for loop. It's way easier for this. So just look at each integer in the tests array and then add to the sum. No issue. And then at the end, you can just say the average is just the sum of the elements divided by how many there are. Well, if we've declared the size beforehand, then we know the size of the array because it doesn't change. And so therefore, the average is the sum over the number of elements. What if we wanted to do the sum of the squares? So the first element squared plus the second element squared plus all the way through. What could we do to modify this?
Use the range-based for loop.
Range-based for loop, and what would I change?
Instead of the plus equals, now we would say plus equals num times num.
Yeah, so here it would just be num times num on the right side. Num num. So yeah, so it's really a simple modification if you want to do something slightly different. Or if you want to know the product of the elements. So the first one times the second one times the third one times the fourth one. Then what we can do is in the for loop is just say times equals instead of plus equals. So they can be easily modified for various problems of this nature. So summing things, averaging, standard deviation, product, all that sort of thing. If you want to know the largest, it's a little more complicated, but it's not really that complicated. So what you typically do is just say, well, the largest could be any of the elements in the array. Could it be the first one, the index 0, 1? Yeah, it could be. So let's just create a variable that's set equal to that first element. And then what if we just march through the array and just say, at each point, if it's larger than the largest value we've seen so far, then is this one the largest now that we've seen? Yeah. So suppose we had 79, 10, and 89. So 79 is the largest we've seen so far. Is 10 larger than the largest we've seen? No, so we don't do anything. Go to 89. Is it larger than the largest thing we've seen? Yeah, so now we update our largest variable. So that's what this if statement and assignment in here is for. So if the observed element right here is bigger than the largest element we've seen, then the largest element, therefore, is the thing at that place. And then we go to the next index and then do the check again. If it's larger, then update. If it's larger for the next one, update. And then after the entire loop is done, once we've iterated all the way through, we just print the largest value. And for those curious, you could use a range-based for loop for this. So you don't actually need the index itself right here. You can just use a range-based for loop, and it works exactly the same. Any questions on these two things? Sum, average, and largest. What if I wanted to find the smallest?
Same as the largest to just reverse that inequality.
Yeah, so you would just reverse this inequality, probably change the name of the variable to smallest, but yeah, so you just flip the inequality here and you're all good. Pretty cool. So when do you use an array? Yeah. If you're only processing the input exactly once and you don't need the values you've already processed later, then do you need an array for this? No. What if I wanted to print the values that the user entered in reverse order? So they enter, like, say, 100 values. I want to print, instead of in this direction, I want to print them in this direction. Do I need an array for that? Yeah, unless you want to maintain 100 variables. You could do that, but is an array a lot easier? Yeah. So if the user, for whatever reason, can have any number of values, do I need an array at that point? So if they can enter any number of values that they want, do I need an array there if I want to print them in reverse order? Yeah, because I can't just add more variables because I need the program to compile. So I do need an array for that. So when do you use it? If you only process data exactly once, you probably don't need it. But if you do need the values at some later point, then you do need an array. So, like, for example, if you want to calculate the largest value, do you need an array for this? No, just input the value and then check if it's larger than the largest value you've seen. And then have the user input again, check if it's larger than the largest you've seen, and update if necessary. So for the sum, average, and largest and smallest, you don't actually need an array for them. What about standard deviation? So easier question. What about the average? So the average, we don't need it. What about standard deviation? So what it does is the sum of the squares of the differences between the elements that were entered and the average. Well, do I need to process the entire list of elements that the user entered in order to know the average? Yeah. So in order to know the average for the standard deviation, I need to process all of the values in the array that were entered. But the standard deviation uses that average and the values that were entered themselves, the actual values that were entered. So for standard deviation, do we need an array? Yeah. So sometimes you do need an array, sometimes you don't. You need to think about what whether you do need him. If you don't actually technically need it, an array sometimes is still a good idea because it's a lot easier to manage. So instead of having to manage 10 separate variables, what you can do is just put them all into one array and then just manage the array itself. So it's a matter of convenience. Sometimes you really do need an array and there's no way around it. But a lot of the time you can get away with it without using it. Let's see. What do we have here? Okay. So, yeah. Because we don't know the sizes of the array, again, there is a way to do it. And I'll invite you to figure out how you actually do that. But let's just say we don't know how to figure out the size of the array. Well, if I have the array partially filled with data, not completely filled, then you need to actually maintain how much of that array is filled. And this is actually a sort of issue when you're trying to write a nice interface to work with an array, to make it easier to use. Because internally, you need to know how full the array actually is. So that could be actually an issue. Okay. I want to actually use this as a point to go over to this. So suppose that this array right here, let's just fill it with values like this. And let's just say these are all user inputted values. All 5 of them are. But then the user, so this may seem not really useful right now, but it will be. Let's just say the user wants to input another value, a 6th value. Well, don't I want to keep these things around, these 5? Yeah, but is there a 6th place that I can put the value that's entered? There isn't a place. So, but is there a way that we can make an array larger? There actually is no way that we can make a single array larger. But can we make a different array that's larger?
Yeah.
Ah, so let's look at this. So let's make a const in I size equal to 5, just like before. But let's just say I want to keep these 5 in, but I want to move them to a different array that's twice as large. So if the user keeps inputting values, I want to make the array larger, but I can't make this array larger. What I could do instead is a level of indirection. So there's a famous phrase that computer science is just adding levels of indirection onto things. So let's make a different array that's twice as large, so it has 10 elements now, and copy the original 5 elements to the second array, and then just leave the other 5 uninitialized. Okay? So how do I make an array that's twice as large? Let's call it array 2.
You say I size times 2.
Yeah, actually this has to be I size. I size times 2. So this array right here has twice as many elements. Well, let's just say that now I want to copy all of the elements in I size to the same places in the second array. What can I do? Well, let's loop over each index in the original array. Well, I'm going to start at 0, because I can. Well, what's the index that I want to go to? Is it I size or I size times 2? I size, right. Because I only want to copy the elements from the first array over to the second one and leave the other ones in the second array uninitialized. So I'm going to go up to I size here, not twice I size, and then I++. So how do I copy the ith element in this array, the first array, to the second array? Array 2 of what? Of I, the index that we're looking at, because I want it to go into the same place in the second array. So array 2 of I equals is assigned to the value what? The original array of I. So in this second array, 79 is going to be copied, 19, then 42, 23, and 10, and the last 5 are uninitialized. I'll see you on Wednesday.